Good day and welcome to my Campus Guide channel. Today we are talking about sectioning in engineering drawing. And if today is your first time visiting my channel, please subscribe. One may ask, what is sectioning? Sectioning is needed and it is very important in our study in engineering drawing. We as engineers, we solve problems. And one of these problems we encounter during analysis of drawing is hidden details. So in this scope of sectioning, we will learn how to avoid, reduce, or even delete entirely hidden details in our drawings. In our study, we'll be cutting objects like this. This is the concept of sectioning. This is a simple torchlight, and taking the first diagram here is the full torchlight. But in this study of sectioning, you will learn how to cut this torchlight into sections. When we are drawing this figure here, we have some parts of the torchlight we are not seeing. That's behind the torchlight and inside it. As engineers, whenever we draw such objects or products, we draw and represent those hidden details with short dashes or with thin short dashes. But in this study of sectioning, you will learn how to cut objects like this into sections to avoid these hidden details we are talking about. For this diagram, we will call the torchlight is our object, and the section we are taking it through, or the knife cutting through, yes, let me call it a knife cutting through this torchlight will be our cutting plane. So let's give an explanation to what sectioning is. When we say sectioning, then we are talking about making a cut in a technical product in order to view the internal details of it. So whenever we make a cut through any engineering product or any technical product so that we can view its internal product, then we are performing sectioning on that product. In this study of sectioning, we imagine the cut through the object. The cut is not permanent on the object, or they do not give us object with permanent cut or that is already sectioned. As we engineers, we imagine a cut through this object so that we can examine them well and also view the hidden details inside this object. We have to know some advantages of sectioning. Why we have to section a particular product, or why we have to section a technical product. One first advantage is sectioning is used to expose the internal features and thereby reduce or delete hidden lines. Whenever we section any product, technical product or image, we get to expose the internal features of this product and therefore reducing the hidden details in it. And also, the sectioning facilitates dimensioning by turning the undesirable hidden lines into visible lines required for dimensioning. When we are talking about dimensioning, we mean giving dimensions to objects. These drawn objects, we give them dimensions. So whenever we have sectioned this product, it facilitates our dimensioning. What do I mean by that? When you have an open cut of an object, you get to know the right dimensions of these internal parts. But whenever they are represented by hidden lines or they are behind the drawing that is not visible to the viewer, dimensioning is tedious. Reading and understanding such diagrams or figures become difficult. For this reason, sectioning facilitates the dimensioning so that we can turn these hidden lines or details into visible ones. So now let's look at some terminologies we are going to meet in our study of sectioning. Our first terminology is cutting plane. Firstly, let's define what is called a plane. Whenever we say a plane, then we are talking about a two-dimensional figure that has no thickness. So the cutting plane, we've already said, is imagined. So you can call this cutting plane an imaginary cutting plane. You imagine a cut through the object you want to section. So the simplest view of this cutting plane is its edge views. So whenever you look at the edge view of the cutting plane, you get a clear and a simple view of the sectioning. It's an imaginary plane, so it is not shown. That's why in the explanation of a plane, we said it has no thickness. So the cutting plane is not represented by a straight thick line, no, for it to appear as an object line. They are represented by a thick long chain at its ends and a thin long and short lines in the middle. So I gave a simple form for it so that it will help you remember it as TLC at ends and TLS in the middle, meaning thick long chain at the end and thin long short lines in the middle. TLC at the ends and TLS in the middle. And these cutting planes are always with arrowheads. What do I mean by arrowheads? They are connected to the cutting planes to indicate the direction in which the cut object is viewed. So you see, whenever there is a cutting plane, they are being assigned an arrow. This arrow gives us or indicates where the object is being viewed after it's been cut. A cutting plane can be continuous or it can be offset. What do I mean by a cutting plane being continuous or offset? When a cutting plane is continuous, that means it runs continuously through this plane, or the object is being cutting. You see, the cutting plane will move continuously through the object is cutting. But when we take the offset, for the offset, the cutting plane is applied. This type of cutting plane is applied when there is change in direction of the cut. Whenever there is change in direction of the cut, then we use this type of offset cutting plane. And also, the offset cutting plane is characterized by alphabet in series. Because for the offset cutting plane, there is change in direction. We characterize this change in direction with alphabet, capital alphabet, to indicate or to label them. Let's talk about the second terminology, which is sections. What is a section? A section is the exposed surface after being subjected to cutting operation. So after we've subjected the object to a cut, the surface we are seeing now, the hidden details that are now shown are called the section. So after the object have undergone a cut, the imaginary cut I say, after the objects have undergone this imaginary cut, what we are seeing, the exposed surface after the cutting operation is being done, is called the section. And under sectioning, we get to hear about sectioning lines, or some call it hatching lines. What do we mean by a section line or hatching line? In our view or in our study in engineering drawing, we will meet many materials inside it. For this reason, they are given conventions so that we can identify them easily. whenever a diagram is given or a figure, how would you know this diagram is made up of? It's an alloy or it's a steel or what? So we've given conventions to these materials we will encounter in our study so that it will make it easier for us to identify them. So the first one is simple straight lines. You see, these diagrams are not drawn to scale. It took me uh, a while to get these drawings. These are just simple lines I joined and it wasn't easy for me. So they are not drawn to scale. But we as engineers, we are to produce quality and accurate lines. The first one is called the cast or malleable ions. So in sectioning, you make section lines like this. Whenever you see a section line like this, then it is giving you an idea that the material you are working on is a cast or is a malleable ion. It's the most common one we use. It's a general use for all materials. The cast or malleable ion is generally used for all materials. And whenever you are getting double lines like this with equal spacing, I've already said it's not drawn to scale. When you get figures with hatching lines like this, that means that material is a steel. But when you get a thin line and short dashes, thin line and short dashes, then this convention is telling us that the material is a bronze, brass, copper, or its compositions. When you see such conventions, that's what it means. But when you get a stack of points, like a connection of points and dots inside a figure or a hatching line representing like a bulk of dot or point, then that material is a concrete. Section lines or hatching lines need to be spaced. We don't just draw them. Whenever you are doing sectioning, we use these hatching lines to section them. We don't just draw them. We have to give them correct spacing. Hatching lines should not be too close nor far apart. You don't make them too close as if they are shaded parts or too far for them to appear as object lines. We give them accurate and equal spacing between them. The lines must have an even spacing. That's for the spacing of section lines or hatching lines. And the inclination of a hatching line. We don't just incline hatching lines at any angle that we want. We incline hatching lines at a particular angle. You can incline a hatching line or a section line to angles of 60 degree, 45 degree, or 30 degrees. But the most preferable or the preferred angle is 45 degrees or 135 degrees to the main outline or to the symmetrical axis. Please take note of this. We incline it to 45 degrees to the main outline or the symmetrical axis we are working with. Let's look at the next terminology, which is sectional views. Sectional views. What do we mean by a sectional view? The sectional view is a special view that reviews the hidden internal details of the sectioned object. So after you've sectioned the object, the view we are seeing, we have many types of it. It's a very special view that reviews these hidden details of the object we've sectioned. Let's look at some characteristics of sectional views. The first one is hidden details of objects behind the sections or cut surface are generally omitted unless they are absolutely essential. What does this mean? This means for the sectional view, we omit the hidden details unless these hidden details they are very essential in our drawing or in our presentation. In this study of sectioning, we are trying our possible best to omit, reduce, or even eradicate these hidden lines or hidden details. So one characteristic of the sectional view is that the hidden details of the object sectioned is omitted. And the second one is a multi-cutting plane within drawing must be treated independently from each other. This means whenever we are sectioning, we have to make sure the cutting plane, you see, we already talked about offset cutting plane, that for the offset cutting plane, there is always a change in direction. So one characteristic of this sectional view we are talking about here is that we have to make sure the sectional view of one do not affect the sectional view of the other. This is what we mean by when there is a multi-cutting plane, we have to treat them independently from others. But in this study, we have some components that are easily recognized in our study. So for such objects or such components, we do not section them. Such components include solid shafts and axle, bolts, screws, studs, rivets, pins, washer, ribs and webs, etc. So for these components in our study, whenever we meet them in any engineering drawing or a technical drawing, we do not section these components because they are easily recognized. There is no need for us to section them. So now let's look at the types of this sectional view we are talking about, how we can display or review hidden details, the types, in what ways can we review these hidden details we are talking about. So the first type of sectional view we are talking about is full sectioning. Full sectioning. For full sectioning, this section view cuts fully through a part. The cutting plane can be along or perpendicular to the longitudinal axis of the object. So for this full sectioning, it cuts through fully through the part we are sectioning. That's for the full section. We also have the second one, which is called half sectioning. For this type of sectioning, only 1/4 of the hollow object. For this one, sometimes it deals mostly with hollow objects and cylindrical objects. So only 1/4 of the hollow object is cut away and the other part is viewed to review the internal details, and it is applied on symmetrical object. So you see, we apply the cutting plane to only this side of the object. So this is a half section. You see, for this half sectioning as compared to the full section, for this one, the cutting plane is running fully through the object we are sectioning, but for the half section, you see, it's only some part of it that is being cut. We cut only some part of it so that we can view the internal details, and also we can also see some of the external details we are talking about. Let's see some other types. We have some minor types of the sectional views, but let's look at this one, the offset sectioning. We've already talked about offset cutting plane, and we said this cutting plane is applied when there is change in direction of the cut. Whenever there is change in direction of the cut, we use the offset cutting plane, and now we are meeting offset sectioning. So what it means is that the offset sectioning is a type of section that is used on complex objects. That means we are talking about objects with a number of important features that cannot be sectioned using a continuous plane. Because these objects are complex, we cannot section them with just a continuous plane. So there will be a change in direction of the cut. So for this one, we do an offset sectioning on it. So therefore, the cutting plane is bent to an angle of 90 degrees to pass through the important features. Please take note of this. that for offset sectioning, we bend the cutting plane to an angle of 90 degrees, nothing else but 90 degrees. This how much we bend the angle to pass through some important features of the object. When we see the diagram here, you see there is a cutting plane here. We have some important views we cannot ignore when we decide to take a continuous cutting plane or a full sectioning for this one. We have some important parts we may not see. For this reason, we run an offset sectioning on it so that we will bend the cutting plane to 90 degrees so that it will cover all the important parts of this object. Now let's look at the revolved or rotated sectioning. For this type of sectioning, the profile of an object in view can be revolved or rotated within the view. Outline is shown with a continuous line. For revolved or rotated sectioning, the object can be revolved or rotated within the view. So that's the part of the revolved or rotated sectioning. The object under view can be revolved or rotated. So after the sectioning, the object is being revolved. You see, is represented, the outline of this section is represented by a continuous line. So after it's been cut, it's revolved or rotated. Let's look at some other types. We have the removed sectioning. What do we mean by removed sectioning? The removed sections are used to show the contour of complicated shapes such as rings and fuselages, blades for jet engines. It is done by passing through an imaginary cutting plane perpendicular to the path, then revolving the cross-section 90 degrees. So let's look at the diagram. For the removed sectioning, we remove the sectioned part so that the it will make our drawing very readable and easily accessible. You see, when you check the diagram here, you see the section part is removed so that the diagram will be easily read. To make our diagram or our drawing readable, we remove the section part to make this diagram very readable. We have some minor type of sectional view which is called the auxiliary section. We didn't talk that much about that one. Let's go to align sectioning. For align sectioning tool, it's a special type of photographic drawing that is used to revolve and align special features of parts to clarify or make them easier to represent in the section. It happens through cylindrical objects with an odd number of features. The next sectioning is called outline sectioning. It's one of the minor sectioning. We do this type of sectioning on the outline of our technical drawing. And now we have something we call thin sectioning. For thin sectioning, you see in most at times in this engineering drawing or in our view of sectioning, after drawing, you see there will be a few space or there will be some gap between some two adjacent sections or rings. You see, after sectioning some two parts, you see there will be a thin gap between them. These gaps are too small to be sectioned. For this reason, we section this part black. In our journey of technical drawing, you get to meet some joint of steels and others which have some space, a thin space in between them, which cannot be sectioned. For this reason, we shade that place entirely black. And the last type of section I would like to talk about is the assembled section. This one we section an assembled part or an assembled figure. Now let's look at some conventional breaks that we have in engineering drawing. What do we mean by conventional breaks? We as engineers in this study, we will meet a lot of materials, and in the drawing we have to indicate that this material was this. You have to make the reader or the person viewing your drawing understand whatever you are doing. We all know that we as engineers, communication is done to us through our technical drawings. So for this reason, your drawing have to give a clear understanding of what it is representing. For this reason, we have conventional breaks. Conventional breaks are used for revolved section views or for shortening the views of an elongated part. So whenever you have a view and you see this part section like this, that means we are talking about a round solid. That means it's a round solid that is being sectioned, or we are talking about a round solid. But when you see that the end or the broken part of this material we are talking about, a section like this, that means that object is a round tubular object. We are talking about a tubular object. But when for this convention, when you see such a convention, that means it's a rectangular metal bar. That means the material we are talking about is a rectangular bar. And also you get to meet things like this. That one, you see the bricks are elongated very well. They have long bricks in it. For that one, then we are talking about a rectangular wood or a wood. They are represented photographically like this. So this is all you need to know about sectioning in engineering drawing. If this information was useful, please subscribe to the channel and share. Thank you.